Today we're going to continue to work with graphs and rules and patterns. On these, we want to both write the rule and describe how the pattern changes and how many tiles are in figure 0. So, for this first one, I kind of dislike the very first one because if you're not paying attention to which thing is which, you still get the right equation. The way that I do these, and I've told you this, it's not the way that most algebra books do them. I usually start with, where does this start on the y-axis? It starts at 2. Plus, every time I move to the right one, how much do I move up or down? I move up 2, so that's 2 plus 2x. If you have 2x plus 2, that's fine. There's nothing wrong with it. Okay? I just think it's easier to do it this way. It also makes it easier to write your description. How does the tile pattern change? The tile pattern starts with 2 tiles. And then adds 2 tiles for the next figure number. All right, so then for this one, we start at 3. So for my rule, I start at 3. Y equals 3 plus. Now, notice they didn't put a dot everywhere. So if I went to the next dot, I would be going over 2 to the right and then up 4. But I want to know, how much do I go up or down when I just move over 1? So when I move to the right 2, I go up 4. If I move to the right just 1, how much am I going up? 2. That's your unit triangle there. So that's plus 2x. The tile pattern starts with 3 tiles. And adds 2 tiles for the next figure number. This one shows exactly the same thing, but it doesn't show the grid. But it still works out the same way. Where do we start? We're starting at 5. Plus, every time I move to the right 1, how much am I going up? 8. So it's 5 plus 8x. So here the tile pattern starts with 5 tiles and adds 8 tiles for the next figure number. Any questions about those first 3? All right, let's look at the next 3. These are a little bit different. We'll still do the same thing. Where do we start? At 8. But here, when we move to the right one, we're not moving up, we're moving down. So we'll call that negative 2. So it'll be 8 minus 2x. So the tile pattern starts with 8 tile. So the tile pattern starts with 8 tiles. Then does what? Yeah. Or you can say removes if you would rather. Removes is slightly shorter, so I'm going to do that. Removes 2 tiles for the next pattern number. All right, so where is this one starting? No, it's not. It's an easy mistake to make. I've heard 8, 9, and 10. One of those is correct. It's 8. Because if that's 10 and these are equally spaced, then each of these must be 2. So y is equal to 8 plus, let's see. Now, how far over have I moved to the right if I go from here to here? It's only 1. Because this is negative 2, right? So the scale on the y-axis is different than it is on the x-axis. You have to be really careful with ones like this. This is 1. So that's negative 1 to negative 2. That's a distance of 1. How much have I moved up? 4. You can't just count the squares on that because each square is not 1 by 1. So this would be 8 plus 4x. So the tile pattern starts with how many tiles? With 8 tiles. Then removes, adds, not removes, my fault. Adds 4 tiles for the next pattern number. Next figure number. I wrote it wrong last time. All right, everybody take a crack at the last one. Feel free to work with your shoulder partner.
You can say negative 4, you can say minus 4, it's the same. Plus, wait, so plus negative 4 minus 4, it's all the same thing. Y equals 4x minus 1. There, is always right.
Yeah, he's actually not your partner. No, those are not the same thing.
Yeah, that's what I was trying to tell you.
negative
Well, but
subtraction can't be
I
negative
just
4x
did it.
plus
I did y equals mx plus b, and T did what?
Oh, okay. Someone said that they did -4 plus 12x, and I'm like, that's not the same thing.
I did y equals 4x minus 12.
That's wrong. That's what I'm telling you.
negative 4x plus
That's not the same thing.
It's a y equals 12.
If you want to do it in y equals mx plus b form, which is fine, the b has to be where you cross the y-axis.
That's what I did. 12 is there.
What did you write? Exactly.
I put the 12 and
No, what did you read to me what you wrote down, please, sir?
y equals 4x minus 12.
4x minus. What?
negative 4x plus.
See,
Negative 4x
you
plus
told me
12.
mine was right.
Could you? No, I didn't. I said mine was right. I said yours is split. I said yours is subtraction.
This is part of why I don't start off in y equals mx plus b form. As a geometry teacher and a calculus teacher, I think it's dumb.
Oh.
See?
I always just do it this way. Where did it start? And then how many tiles are you adding or subtracting each time, which is why it's times x. Each time you go to the next figure number, we're going to add or subtract a certain number. So the pattern starts with 12 tiles. And then removes 4 tiles. For the next figure number. Okay, questions about that? All right, so now we're going to reverse the process. We want to graph the following rules without first making a table. Johnny, this is what you and I were talking about off the homework today. Parts A and B could go on one set of axes, and then parts C and D on another set. Label each line with its equation, y-intercept, that's where it crosses the x-axis, and a growth triangle. It's another way of saying the unit triangle. All right, I'm going to make this somewhat smaller. And I'll do A and B with you, and then you can do C and D after that. So I need some axes. All right, so for this first one, y is equal to 4x plus 3. I'm giving them to you in this order because your book is always going to give them to you in this order. Where did we start on the y-axis? At 3. And if you forget, then think about this for just a second. On the y-axis, what is the value of x?
Figure number?
Now, just what is the value of x at any point? 0. If I substitute 0 into this, 4 times 0 is 0, plus 3 is 3. And then my growth triangle is 4. Every time I move over 1, I'm going to go up 4 spaces. If I'm doing that without a ruler, I usually do it until it goes off my grid area, because otherwise I have a tendency to miss those. About like that. So here's a growth triangle. That's 1 and that's 4. Here's the y-intercept. The coordinates for that point are 0, 3. And it said label it with the equation, y equals 4x plus 3. We'll do the other one in a different color. So this one's a little bit different. It's y is just 3x. And you're like, well, they didn't tell me where to start. Well, they did. They just didn't write it down. Pardon?
Do you start at 0?
Yep, that's exactly right. You start at 0 because this is 3x is equal to 3x plus 0. So we're going to start at 0 and grow by 3 each time we move to the right one. That's going to go right through my 4. So that's y is equal to 3x. And its y-intercept is the origin, 0, 0. All right. Please try the next two on your own. Or you can use your shoulder partner to help you, or someone near you if your shoulder partner has abandoned you. hopefully you're rapidly finishing up and that yours looks something like mine. Notice on that last one, it didn't have a number in front of x, but how many x's do we have? One. So our growth triangle is just going to be one for every one that we move to the right. All right, let's move on to page 3. All right, so here we want to sketch a graph that fits each description and then label each line with its equation. You can put all the graphs on one set of axes if you label the lines clearly. Use what you know about the growth pattern in figure 0 to help you. All right. Oh, I thought I had it online. I did not. Also didn't mean to go quite that far down. I don't think I'm going to need that far. Okay, so for this first one, it says a pattern that has 3 tiles in figure 0 and adds 4 tiles for each new figure. So where am I going to start? On the y-axis. Then what am I going to do? Do what? Grow by 4 each time we do what? Each time we move to the right one, yeah. So the right one up 4. So it's going to look something like that. Be sure you put arrows on the ends of your lines to show that those don't stop. And now we need the equation for this. I'll take a volunteer. Who can tell me the equation for this one? Yes, Christian.
Y equals 3 plus 4x.
Exactly right. Y equals 3 plus 4x or 4x plus 3. All right, let's see. A pattern that shrinks by 3 tiles between figures and starts with 5 tiles in figure 0. Okay, who can explain to me how to graph that? I'll take a volunteer again. Ben?
You start at 5 tiles on the y-axis,
Okay, on the y-axis, we're going to start at 5.
and each time it goes to the right one, you go down by 3.
All right, so each time we go to the right one, we go down 3. Exactly right. So that's going to look like this. Someone else who hasn't volunteered yet, give me the equation for this, or the rule for this line. Yes, sir.
Y equals 5 minus 3x.
Good. Y is equal to 5 minus 3x. And then part C on this one, they want a pattern that has 2 tiles in every single one of its figures. Well, that's a boring tile pattern, isn't it? It always has 2. And the equation is equally boring. It's y is always 2. We don't take away tiles or add tiles, so there is no plus anything x. I suppose if you had to do it, you could say y equals 2 plus 0x, but there's no need to. All right. So now let's reverse the process. Describe the pattern represented by the rule y equals negative 2x plus 13. What do we know about this? What's one thing we immediately know?
Start to 13.
All right. We start with 13 tiles. Then what?
Subtract by 2.
Okay, we subtract 2 for each additional figure number. Okay, any questions about that? Okie dokie.